All right, this is part 2. We are going to continue solving compound inequalities. We've looked at the difference between and or statements, and now we're going to solve a few ors. All right, so it says solve and graph the solution. All right, so A part says 3y minus 5 less than negative 8, or 2y minus 1 greater than 5. So I'm going to add 5 to both sides. So I'm going to bring down my 3y. I'm going to bring down my less than sign. Negative 8 plus 5 is negative 3. I'm going to divide by a positive 3. If I divide by a positive number, my symbol does not change, so y less than negative 1. Okay, or the second part, I'm going to add 1. I've got 2y. Bring down my greater than. 5 plus 1 is 6. Divide by 2. Y is greater than. 6 divided by 2 is 3. All right, so I'm going to graph this to show the solution set. All right, so now that I have my graph, I'm going to say y less than negative 1. So I need an open circle at negative 1, and less than would be going to the left. Everything up to negative 1, but not including negative 1. Less than negative 1. All right, and the second part, y greater than 3. So I need an open circle on 3. And everything greater than 3. All right, so everything shaded to the left of negative 1 and to the right of 3 would be a solution for this inequality or this inequality. So it doesn't have to be a solution for both. It has to be one or the other. All right, B part. This one is or as well. So I'm going to subtract 1 from both sides. I've got 2p. Bring down my less than, negative 4 minus 1 is negative 5. Divide by 2. P is less than, I divided by a positive 2, so my inequality stays the same. Negative 2.5. 2 goes into 4 twice, 1 left over. Negative 2.5 is the same as negative 2.5. All right, or I'm going to subtract 3 from both sides here. I've got negative 8p comes down. Bring down my inequality symbol. Negative 1 minus 3 is negative 4. This time I'm going to divide by negative 8. Remember, when we divide by negative, our inequality changes direction, so it's going to become greater than or equal to. 2 negatives make this a positive. 4 divided by 8 is 1 over 2, or 1/2. So that reduces to 1/2. All right, so to graph this inequality, all right, I'm first going to put an open circle at negative 2.5. Negative 2.5 would be halfway between negative 2 and negative 3. So an open circle here. Less than goes to the left. Every number to the left of negative 2.5 is less than that number. Now I'm going to put a closed circle greater than or equal to 1/2. 1/2 is going to be halfway between 0 and 1. So I'm going to need a closed circle here. And this one is greater than or equal to. So closed circle and shaded to the right. Again, because this is an or statement, an inequality using the word or means it has to make this inequality true or this one, but not both at the same time. All right, the last example, we're going to look at a real life problem. All right, so it says an electronic device may fall outside of its operating temperature range. Write an inequality that represents the possible operating temperatures in degrees Fahrenheit of the smartphone. Then describe a situation in which the phone may be outside of the operating range. All right, so as you can see here, the operating temperature goes from 0 degrees Celsius to 35 degrees Celsius. All right, so the first thing I notice is that this wants it in degrees Fahrenheit. All right, so that is something we're going to have to remember or look up from a previous lesson. So don't forget how to convert from Celsius to Fahrenheit. All right, so first thing we're going to do is just use what we're given and go ahead and set up an inequality. So we know it's between 0 and 35 degrees Celsius. So we've got 0 less than or equal to Celsius degrees, and then that is less than or equal to 35 degrees. All right, so think back to a previous lesson. If you remember, Celsius is equal to 5/9 times your degrees in Fahrenheit minus 32 degrees. So if you know that, you can take this formula and substitute this in place of C. All right, so let's do that. So we've got 0 less than or equal to. So instead of C, we're going to put 5/9 times Fahrenheit minus 32 degrees. And that's less than or equal to 35. All right, now that we can set this up into two inequalities, we can solve. So 0 less than or equal to 5/9 times Fahrenheit minus 32 and 5/9 times Fahrenheit minus 32 is less than or equal to 35 degrees. All right, so we're multiplying by 5/9. In order to get rid of that fraction, we have to multiply by the reciprocal. So the reciprocal of 5/9 is 9/5, and we have to multiply that on both sides of the inequality. All right, 0 times anything is just 0. So I know that I can still write 0 less than or equal to. But 5 times 9 is 45. 45 over 45 cancels or reduces to 1. So we can bring down just f minus 32. So add 32 to both sides. And we have either 32 is less than or equal to f, or f is greater than or equal to 32. So in Fahrenheit, that means the temperature has to be 32 degrees or higher, which is freezing. 32 degrees is freezing. It's got to be at freezing or higher. All right, on the other side, we're going to multiply by 9/5 again in order to get rid of the fraction. So we're going to have f minus 32 less than or equal to, we need to do 35 times 5/9. 9/5. We're doing the reciprocal. 35 times 9/5 equals 63. Now we need to add 32 to that. All right, so 3 and 2 make 5, 6 and 3 make 9. So the degrees has to be less than or equal to 95 or greater than or equal to 32. So we can write this as compound inequality like this. So the solution is from 32 degrees to 95 degrees Fahrenheit. And that would be the operating temperature for a smartphone. So if you're below freezing, below 32 degrees, or if you're at a temperature above 95 degrees, your smartphone may not work. Is this true? I have no idea what the operating temperature for a smartphone is, but it does make sense. I would say this is pretty close, or maybe this is pretty relevant to, you would not want your smartphone to be below freezing, and you certainly would not want to leave your phone out in temperatures that are in excess of 95 degrees. So, anyways, if you want to check your answers, you can take 32 and plug it back in up here. And see if you get 0 and 35 as your Celsius degrees. If you do, that means we did it correctly.